I'm Yoram Yovel, a psychiatrist and neuroscientist at the Hebrew University of Jerusalem. And when I was 14 years old, my father died. I was sitting in class when my mother and my grandfather knocked on the door and asked me out to the corridor. "Your father's very sick," my mother said. "Your father's dead." And then I felt it, a crushing pain in my chest. I can still feel a glimpse of it whenever I think of my father. He was a doctor, a scientist, a paratrooper. He was a young, strong, happy, healthy man. He was my hero. And his death broke my heart. Do you remember the pain you felt when someone broke your heart, when your best friend or your mother died? Or the man you loved told you that he doesn't love you anymore? You probably do. But why do we feel mental pain at all? And what's the relationship between physical and mental pain? And most importantly, how can we make mental pain better? Together with many scientists and physicians, I spent years searching for answers to these questions. Now, growing up, I never heard the words, "We want you to be a doctor and a brain scientist like your father." But somehow, that's what happened. 12 years after my father died, I was a graduate student at Dr. Eric Kandel's lab at Columbia University. Eric, who won the Nobel Prize for his work on the molecular basis of memory, was the ultimate mentor, passionate, energetic, and inspiring. Under his guidance, I studied receptor. It's a protein that's part of a synapse, and synapses are structures through which nerve cells communicate with each other. Now, that receptor was a GPCR. That's a G protein coupled receptor. I'll explain what this means in a minute, and then you'll understand what this stack of markers is doing here. And when I did that, I didn't really realize that work on that receptor, which seemed completely unrelated to my future work as a clinical psychiatrist, would one day help us in our search for better treatments for physical and mental pain. Now, a big step along that way was the work of Jaak Panksepp, my other great scientific mentor. In a classical experiment, Panksepp separated puppies from their mothers for 15 minutes, never more than that, because he loved animals. When puppies lose their mothers, they make a sound, which is called the separation distress cry. And it goes like this. Puppies do it, kittens do it, babies do it, all young mammals do it when they're in pain or when they miss their mothers. And we all know how this cry makes us feel inside. Panksepp and his colleagues then traced the brain circuits that produce these cries in guinea pigs, and they made a startling discovery, that these are the very same circuits that are active when humans feel sad and when they experience depression. And these circuits are also part of the brain's pain matrix that mediates our sensations of physical and mental pain. But why are we born with this terrible gift hardwired into our brains? Well, probably because, like any pain, mental pain is an alarm system. Its task is to prevent damage. When babies lose their mothers, they hurt and they cry, which brings their mothers back, and it also makes them seek their mothers. In the wild, this is life-saving. Puppies and babies cannot survive without their mothers. So now we know why we have mental pain. It is the glue that keeps us together in couples, in families, in communities. And when someone we love goes away or is taken away from us, it's this pain which draws us back together. And once we realize this, then we can answer an age-old question that poets and philosophers have been asking for thousands of years. Does love always hurt? What do you think? Does love always hurt? Yes, love always hurts, of course, and because that's what it's supposed to do. Mental pain is simply the high price, the very high price that we pay for our ability to love. And personally, and I've been around the block a couple of times, personally I think it's worth it. But we're not entirely defenseless against pain, because our brains produce endorphins, or endogenous opioids, our very own feel-good molecules, the natural remedy for both physical and mental pain. Endorphins are released in the brain during aerobic exercise or when we're close to someone we love, and immediately after severe injuries. And we now know what endorphins do. They attach to special receptors in the brain, and the most important among them are mu-opioid receptors. And just like the receptor I worked on in Kandel's lab, mu-opioid receptors are GPCR. Here's how they work. Like all GPCRs, mu-opioid receptors are made of 7 spirals or loops that are stacked together, sticking through both sides of the cell membrane. Like this, okay? And when endorphins attach to mu-opioid receptors from the outside, they cause them to change their shape, like this, okay? And this triggers a series of events inside the neurons which eventually ease the pain. Now, forget the molecules for a second. When you hug someone you love, who's suffering from severe physical or mental pain, you actually cause her brain to release endorphins. They attach to mu-opioid receptors in her synapses and turn them on, and they soothe her pain. And yet, sometimes, mental pain gets so intense that no amount of love can soothe it. But medicine has powerful drugs that can ease any physical pain. These are the narcotics, or opioids, like morphine. Narcotics work mainly by activating mu-opioid receptors. But if so, can narcotics also treat the pain of separation? It was Jaak Panksepp who found the answer. Panksepp gave his puppies in a separation experiment tiny, tiny doses of morphine, lower than the lowest doses that are used to treat physical pain. And his puppies immediately stopped crying and started playing with each other as if they no longer missed their mothers. Let's go to humans now. When mental pain in humans becomes too intense to bear, some people, will do anything to stop it, even try to kill themselves. Indeed, and I'm saying this as a clinical psychiatrist, unbearable mental pain is a huge risk factor for suicide. But if narcotics treat physical pain, and if they can soothe the mental pain of separation, can they also help suicidal people become less suicidal? A few years ago, together with Panksepp and other colleagues, my research team conducted a clinical trial. We gave people who were severely suicidal very low doses of a narcotic drug, buprenorphine, called buprenorphine, for 4 weeks. We discovered that tiny, tiny doses of buprenorphine, which are too low to treat physical pain, help many of them become less suicidal. But narcotics are extremely dangerous drugs. They may cause addiction, and they're lethal in overdose. In contrast, endorphins are not lethal in overdose, and they're much less likely to cause addiction. So narcotics and endorphins probably activate mu-opioid receptors in different ways. Now, if we could find drugs that activate mu-opioid receptors in a way that resembles how endorphins activate them, we might be able to treat physical and mental pain without some of the dangerous side effects of narcotics. And when my research team came to this conclusion, I suddenly remembered what I had learned in Kandel's lab many, many years ago. Some GPCRs can be activated by 2 different drugs at the same time. And when this happens, the result may be different from what happens when they're activated by just 1 drug. So our research team then used molecular computing technologies to create a detailed virtual model of the human mu-opioid receptor. And then, With the help of programs known as molecular docking algorithms, we screened thousands of existing drugs on our virtual model of the receptor. Eventually, we found a way to teach an old dog, that's the human mu opioid receptor, some new tricks. We found two drugs that are not narcotics, and they work together in very, very small doses to activate the human mu opioid receptor. I'm not telling you their names because we still have to run many tests and clinical trials before we can be certain that their combination does exactly what we think it does. But both of these drugs have been around for many, many years, and they've been used by millions of people, so we know that they're safe for humans. Here's our bottom line. Let's summarize what we've seen. First and foremost, mental pain is real. It's hardwired into our brains. And mental pain is an essential part of mourning and depression and sadness. And when it gets severe enough, it can actually make people suicidal. Endorphins are our brain's natural remedy for physical and mental pain. And they work mainly, not exclusively, but mainly by activating mu opioid receptors. Now, narcotics also activate mu opioid receptors, but in a way that causes addiction and can lead to death. And this is why narcotics are so dangerous. New computational technologies have helped us identify two existing drugs that together may treat physical and mental pain without some of the severe side effects of narcotics. However, this is still work in progress. It will be a few years before it may become an approved treatment. But, and this is the last thing I'm going to say, regardless of drugs, you have the ability to help family and friends who are in severe physical or mental pain. Thank you very much.
恳请点赞，订阅我们的频道，一起学习演讲中的实用英语。